Welcome back, everyone. Today, we're going to discuss some groundbreaking research from the Arctic that may challenge our understanding of climate change. You might be surprised to learn that, contrary to expectations, the Arctic sea ice has slowed its rate of melting in the past 2 decades. But what does this mean for our planet, and why should we care? Stick around, because what seems like good news at first glance actually has deeper implications for our future. Let's dive into the details. Published in the journal Geophysical Research Letters, the research team led by Dr. Mark England at the University of Exeter examined over 40 years of Arctic sea ice data from 1979 to the present day. What they found is remarkable. While the ice has continued to shrink overall, the rate of decline has significantly slowed in the last 2 decades. In fact, since 2005, the decline in sea ice extent has been statistically insignificant. This is a surprising revelation, considering the ongoing rise in global temperatures driven by human activities. To put this into context, when we look at satellite data from 1979 onwards, we see that the September sea ice extent, when the ice is at its minimum for the year, has been halved. So the big question is, why has this slowdown occurred, especially with rising carbon dioxide emissions and accelerating global warming? The primary explanation for this slowdown lies in natural climate variability. Specifically, scientists are pointing to fluctuations in ocean currents in the Atlantic and Pacific Oceans, which have temporarily limited the amount of warm water flowing into the Arctic. These multi-decadal shifts in ocean currents are not unusual in the long-term climate cycles, and they appear to have momentarily offset some of the warming effects in the region. But here's the catch. These oceanic fluctuations are only temporary. The science shows that this reprieve will likely end in the next 5 to 10 years, with the sea ice loss accelerating again at nearly double the long-term rate. The implications of this temporary slowdown are clear. It's a pause, not a reversal. While the natural variations have slowed the melting for now, this is not a sign of a recovery. Rather, it's a brief window of respite in the broader context of a rapidly warming planet. We know that the Arctic is warming at more than twice the rate of the global average, and with every degree of warming, the region's ice, which has a reflective white surface, is being replaced by dark ocean water that absorbs heat rather than reflects it. This process, known as the albedo effect, accelerates global warming. Even without the dramatic loss of sea ice, the Arctic is still experiencing significant environmental change. The sea ice in the Arctic Ocean has thinned over the past decades, and in some regions it's become more fragile. As the ice thins, it becomes more vulnerable to melting from below, warmed by the ocean, and from above, warmed by the atmosphere. These changes have cascading effects, not just for the region itself, but for the entire planet. The Arctic plays a crucial role in regulating the Earth's climate, acting as a kind of global air conditioner by reflecting sunlight away from the planet. As the ice melts, it exposes dark ocean waters that absorb heat, creating a feedback loop that further accelerates global warming. The loss of sea ice also threatens species that depend on it for their survival, such as polar bears, seals, and walruses. These animals rely on the ice for hunting, breeding, and migration. As the ice disappears, they lose their habitat, and their populations face dire consequences. Moreover, the Arctic's role as a carbon sink, absorbing and storing carbon dioxide from the atmosphere, makes it even more critical in the fight against climate change. As the ice melts, permafrost that has been frozen for thousands of years is beginning to thaw, releasing stored carbon and methane into the atmosphere. Methane is a much more potent greenhouse gas than CO2, and its release could trigger even faster warming in a dangerous feedback loop. While the research highlights the temporary slowdown, it's essential to remember that the long-term prognosis for the Arctic is still grim. The study indicates that the Arctic is heading toward an ice-free summer within this century, a scenario that would have profound impacts on global sea levels, weather patterns, and ecosystems. If we reach an ice-free Arctic, it would significantly alter ocean circulation patterns, influencing weather systems around the world. Additionally, the Arctic's loss of ice would increase the rate at which global temperatures rise, further accelerating the melting of ice in other parts of the world, such as Greenland and Antarctica. This brings us to a critical point. The research tells us that the Arctic may be temporarily pausing its ice loss, but the broader picture is unchanged. Global temperatures are still rising, carbon emissions are still increasing, and the consequences of a warmer planet are becoming more and more apparent. We cannot afford to take this slowdown as a sign that we've turned a corner in the climate crisis. Instead, it's a stark reminder that the forces driving climate change are still very much at work, and the clock is ticking. Despite this brief reprieve, the urgency of tackling climate change remains unchanged. The science is clear. We must drastically reduce our carbon emissions, transition to renewable energy sources, and invest in sustainable practices to avoid the worst impacts of a warming planet. While the natural variations in ocean currents have given us a temporary pause in the melting of Arctic sea ice, we must not be complacent. This slowdown is not a reversal of the trend. It is a temporary delay, and once these natural fluctuations end, we will likely see the sea ice loss resume at an even faster pace. So, what can we do about it? First and foremost, reducing our carbon emissions is crucial. This means investing in clean energy solutions, transitioning away from fossil fuels, and pushing for stronger climate policies that prioritize environmental sustainability. Individuals can also take action by supporting sustainable practices, reducing waste, and advocating for policies that protect our planet. Each step, no matter how small, can contribute to the larger effort to combat climate change. The research from the Arctic serves as a reminder that the future is not set in stone. While the next few years will likely be critical in determining the long-term trajectory of our climate, we still have the power to shape that future. But time is running out. The temporary slowdown in sea ice loss may have bought us some time, but the clock is ticking, and the stakes are high. In conclusion, while the slowdown in Arctic sea ice melting may seem like good news on the surface, it's merely a brief interlude in a much larger, more pressing issue. The science remains clear. Climate change is real, it's human-driven, and it poses serious threats to our world. The need for urgent action is more critical than ever. Let's not be distracted by temporary variations in the climate system. Our focus must remain on reducing emissions, transitioning to renewable energy, and taking bold steps to mitigate the impacts of climate change before it's too late. Thank you for watching. If you found this in-depth analysis insightful, please like, share, and subscribe for more updates on climate science and the urgent steps we must take to secure a sustainable future. Stay informed, stay engaged, and let's work together to address the climate crisis before it's too late.